just a generic binomial. Usually you're going to be factoring using the greatest common factor. Take it outside, and then inside the bracket we're going to keep our leftovers. Does everyone understand this concept? Okay, good. So factoring using greatest common factor is very straightforward. Now, we learned when I first introduced quadratic functions to you guys, we learned that the standard form of a quadratic quadratic equation looks like this. Y is equal to ax squared plus bx plus c. That is the standard form of a quadratic equation. The definition of factored form, my equation number 2, that's going to be y is equal to x plus a number, plus or minus a number. Let's call that number a, and x plus or minus another number. We'll call this number a, this number b. That's factored form of a quadratic equation. Now, in Unit 7, you learn that by foiling, if you have type 2 binomials, we can use FOIL to go from factored form to standard form. Now I'm going to teach you how to go from standard form to factored form. So when you are given usually a trinomial, you should be able to go to factored form and produce two binomials. Go from having a trinomial and make that turn into two binomials. Now the reason why we have two separate brackets or two binomial expressions, if I take this equation here, I could rewrite this as x minus x plus 2, x minus 1 for this particular graph. The reason I got those two values is that each binomial for a quadratic equation, when it's written in factored form, actually represents the x-intercepts of the graph. So factored form always gives you your x-intercepts, okay? But when you look at this closely, I have an x plus 2 inside the bracket. However, my x-intercept is actually a negative 2. Over here I have x minus 1 inside the bracket. My x-intercept is actually a positive 1. And the reason for that is when you're solving for your x-intercept, I'm going to take this expression outside of the bracket, and if I set it equal to 0, then I can actually solve for the value of x. So x is actually equal to negative 2. And when you take x minus 1 and set it equal to 0, x is actually equal to positive 1. So my two values of x actually correspond to the x-intercept. So whenever you see a quadratic equation written in factored form, you should connect that with solving for the x-intercepts of your graph. Now I'm actually going to teach you the trial and error method. And the trial and error method is the best method for factoring and when you're trying to get a trinomial into two binomials. So trial and error. However, there are a lot of steps involved. And the good thing is I'm taping this so that you can keep watching the seminar until you remember the process. It can be very easy if you follow the steps in the right order. However, if you mix up steps, then you're not going to get the right answer. So pay really close attention. So our example doesn't correspond to that graph. That's just a picture of another quadratic function. Let's start off with an easy example of factoring. Okay. So the reason why it's called trial and error is because you have to kind of try, because numbers have a lot of different factors, sometimes you have to try more than one combination in order to get the right answer. So step number 1 is going to involve breaking down, just like I was breaking down with factor trees, breaking down my A term as well as my C term. So when you are doing this, you don't worry about positive or negative numbers. And whenever you're doing trial and error, the way you show your work, draw a big X in the middle. That signifies to your teacher that you're using the trial and error method, and all of the steps fall around this big X in the middle. So first of all, I'm going to break down X squared. The only way to break down X squared is X times X. Can someone tell me two numbers that multiply to 6? There are different combinations, but what are two specific numbers? Samisa? 3 and 2. Okay, so we're going to try this combination and see if it works out. Okay, so now we're going to cross multiply. 3 times x, so the first, we've already, sorry, I'm getting ahead of myself. Step 1 is to break down A and C. Step 2 is to cross multiply. So 3 times the number across from it is 3x. 2 times x is 2x. That's all you have to do for step 2. Step 3 involves the term that I've kind of ignored up to this point. What is the one term that I have not dealt with? The b term. That's my middle term, my negative 5x. So negative 5x, I've already dealt with products. Negative 5x represents the sum. So using this whole combination, adding or subtracting to the sum of a number. So I want to play with the signs in front of my 3x and my 2x to figure out if it's possible to play with those numbers in order to get a negative 5x. So can someone tell me what those signs have to be in order to come up with negative 5x? Wilma? Very good. Negative 3x and a negative 2x. If we do that operation, negative 3x minus 2x, we will get a negative 5x. So now this is where we start plugging in the negatives and the positives. The way that I got 3x in the first place was cross-multiplying the 3 and the x. So now, because I have to make it negative, I'm going to put the negative in the second column. We always put negatives and positives in the second column. We got 2x by cross-multiplying the 2 and the x. So if I'm going to want to make this negative, I have to put the negative in this column to get negative 2x. Okay, so my final answer, I'm looking to put two binomials, to turn this trinomial into an equation, factored equation with two binomials. But before I can do that, after you figure out the signs, you have to double check your first step, your very first step, okay? Does x times x still multiply to x squared? Yes. Negative 3 times negative 2, does that give me positive 6? Yes. So that means I know this is the right combination, and I can put my final answer. Whatever is on your top line of, this is your process showing your work, whatever is in the top line goes into your first binomial. Whatever is in your bottom line goes into another binomial. And now you can check your answer by doing FOIL, like I taught you in Unit 7. X times x, if you do FOIL on this equation, you should get your original equation. Okay? Now this is not going to, you're not always going to get the right answer, even if you're breaking down the numbers correctly. So that's why this is called the trial and error method. Let's try a different combination of numbers for this particular example. Same equation, but different combination of numbers. Okay, so I'm going to still break down my x squared because there's no other way to break down x squared. What other two numbers multiply to 6 besides 3 and 2? Yep. 1 and 6, so we can write 6 and 1. Okay, if I cross multiply now, 6 times x is 6x, 1 times x is 1x. Step 3, I want to play with the signs in front of the numbers in order to get my middle term, negative 5x. Can I play with 6 and 1 in order to get negative 5? x